Welcome. My name is Clayton. I'm one of the tutors in the Natural Sciences Tutoring Center at SCC. Today we're going to be talking about vectors. We already had a video on fundamentals of vectors, so this is going to be what we'll call routine vectors. So these are vectors that you're going to see pretty often in any given physics class. So what I did here was I just designed some problem here. We're going to read it. I'm going to have it down here at the bottom so that you can actually read it because my handwriting is abysmal. And we can jump right into solving this thing. All right, so the problem is Susan runs the following route from her house in her training for a marathon. She runs 4 miles at 25 degrees north of east, 6 miles at 15 degrees west of south, 3 miles at 32 degrees east of south, 5 miles at 5 degrees south of east, and 3 miles at 50 degrees west of north. So first and foremost, all of these are clearly vectors. They have both a magnitude and a direction. If you watched the last video, those vectors were on the cardinal direction. So it was either north, south, or east. We can see here, these are at some angle in between our cardinal directions. So each of these vectors has a component in the x-axis and in the y-axis. All right, so why don't we just go ahead and get started. I am going to probably erase this. I'm going to keep the question up at the bottom, and I'm going to build the diagram for it that we'll be working off of. All right, so give me 1 second. I'll be right back. Welcome back. So as you can see, I have drawn the diagram of all of these vectors. Just a couple things to note here. The angles as described, I just want to make sure that we're drawing these correctly, right? This red one was 4 miles at 25 degrees north of east. So I want to make sure this angle is north of or from east. So if I go east, take north from there, that covers this area in here. That's this guy and not this one up here. We don't care about that angle. Wasn't described to us. So that's one thing just to make sure that we're being diligent about. So you can see here, not all of them were, this one is east of south. This one is south of east. Those are two very different things, as you can see, denoted by these different angles here. Okay, so that's one thing just to be wary of. Secondarily, I will cover the trig functions just for our first one here, this red one. But after that, I'm going to assume that you're comfortable with the trigonometry. There will be another video that covers your trig functions, sine, cosine, tangent, and the Pythagorean theorem. So if you're struggling with that kind of thing, go ahead and look for that video. We're not going to do all that right here. All right, so first things first, we need to build our net x and net y equations for our displacement vector here, right? The question is, what is the resultant vector? So let's jump right into it. I know that if I pull this red one out, it looks like this. Okay, so here we have our red vector just kind of pulled out so we can examine this one. If I'm looking at the x portion of this, which is what is going to go in our net x equation, I can see the relationship. This is the adjacent side in regards to our reference angle, and I know the hypotenuse. The hypotenuse is 4 miles. So I'm going to say that cosine of 25 degrees equals adjacent over hypotenuse, x over 4 miles. I want to solve for x. My solution for this unknown is what goes up here. So with a little algebra, 4 miles times cosine of 25 degrees equals x. And keep in mind, this is all in miles, but I'm going to shorten this up. I'm going to say 4 cosine 25 equals x. And I know this is a distance, so I'm going to keep that in the back of my mind. All right, so this is to the right, which is positive. So this is 4 cosine 25 now we're going to get our y portion of this vector. All right, so let's do that over here. I know that sine of 25 degrees equals opposite over hypotenuse. Y over 4 miles. Once again, we're going to solve for y. So 4 miles times the sine of 25 degrees equals y. Y equals, for short again, 4 sine 25. And again, this now is up. So I'm going to call that positive 4 sine 25. All right. So I'm going to erase this here, and we will jump into the next one. All right, so we just finished that first one. Let's continue. I'm going to go ahead and just go clockwise around here as far as the colors are concerned. I can't remember what order they were written in. So now I want my x and y portion. The x portion is positive. So I'm going to say, okay, this is the adjacent side. So that is 5 miles, so plus 5 cosine 5 degrees. And in the y direction, this is negative. This is going down to meet our point here. So this will be minus 5 miles. That's the opposite side from this angle. So that's sine 5 degrees. All right, takes care of that one. Our orange one is next. Let's see here. So this is our x portion right here. There's x, there's y. Now our reference angle says that we want the sine here. So, and again, this is in the right, so this is positive. So plus 3 miles. Oh, I'm not going to write miles, my bad. So 3 sine 32 degrees. And we are again going down. So this is negative in the y direction, minus 3. And again, we want this adjacent side now because that's the y portion of this. So this will be cosine 32. All right, blue one now. We have in the x direction right here. That is negative. That's to the left. So I already know this is going to be minus something. 6, and in the x, that's going to be the opposite side from our reference angle. So that's 6 sine of 15 degrees. In the y direction, it is also negative, and I want this adjacent side right here. So this will be 6 cosine 15. So minus 6 cosine 15. Pink. Oh, it's the last one. All right. Excellent. So now we have the x is in the negative direction once again. And this is the opposite side from our reference angle. Here's a reference angle. I want this side for x. So this is going to be minus, it's the opposite side, so 3 sine of 50 degrees. And it is positive in the y direction here. So we will call this 3. This is the, oh, I guess I should look at this side right here. This is the adjacent side from our reference angle. So this is plus 3 cosine, I can't remember what I said, 50 degrees. Okay, so here is our total net x equation and our total net y equation. All we have to do is add these together to get our overall x and y for our resultant vector. All right, so we're going to do a little math here. I'm going to throw it in my calculator, and we will solve for our x, and then we will solve for our y. All right, so we have 4 cosine 25 plus 5 cosine 5 plus 3 sine 32 minus 6 sine of 15 minus 3 sine of 50 equals. All right. Okay, so that was 6.34 miles in the x direction. That is positive 6.34. All right, let's do our net y equation now. So we'll add all these together, do a little calculator work, and see what this comes out to. So we have 4 sine 25 minus 5 sine 5 degrees minus 3 cosine 32 minus 6 cosine 15 plus 3 cosine 50. Okay, so for our net y, this equals negative 5.16, and again, this is miles. Okay, perfect. So what we can do here is build our resultant vector. So from whatever, Susan's house, whoever's person name I used, we're going to go to the right. Maybe I should start a little lower. 6.34 to the right. So that's 6.34 miles. And then this is down. So from here, we're going to go down 5.16 miles. So something particular to me personally, again, this is only a direction. This negative is only direction. So as soon as I draw my triangle, I don't need it anymore. That says down. Well, guess what? I drew it down. I can see that I drew it down, so I don't need to, I'm not going to put it down here and then also say negative 5.16. This is just a magnitude. This tells me the direction of this thing, okay? So I can see the direction if I do this. Now I want this resultant vector right here. All right, so I'm going to erase a few things on the board. I'm going to clear this stuff. No, I'm going to clear this off, and we'll be right back. Okay, perfect. So we got a little space here. So now we have our x, we have our y, and we're solving for r, our resultant vector. So this is a right triangle. We're going to use Pythagorean Theorem. So again, that's a squared plus b squared equals c squared. But we didn't label our stuff like that, so we're going to substitute here. X squared plus y squared equals r squared. And now I could plug this negative in here. Any negative number squared is a positive. But again, as soon as I'm done drawing my triangle, I do away with these negatives and positives because I don't need them. I can see which direction this is in. I don't need a negative to tell me once again that this is down. Okay? So I'm going to go ahead and do away with those. So we have, in the x direction, 6.34 miles, that's squared, plus 5.16 miles squared equals r squared. So I know that r equals the square root of this whole thing, 6.34 miles squared plus 5.16 miles squared. And I don't know if you remember, I think I learned this in like geometry, in high school. This is like the distance formula or whatever they call it. I can't remember, to be honest with you. But this is what it looks like, because that's exactly what you're doing. You were solving vectors in high school geometry. You might not even have known it. But yeah, this is that distance formula. So I'm going to go ahead and plug all this into the calculator here. So 6.34 squared plus 5.16 squared equals, and then I'll take that square root, 8.17. All right, so here we have 8.17 miles. So this is the magnitude of our vector. We're halfway there. Now we need to solve for the direction. So the direction, I use this orange marker here, the direction is right here, and we'll call this theta. So we need to know this angle right here. So give me another second. I'm going to clear this stuff off the board. I think we're done with that for now. And we'll be right back to solve the direction of this guy. Okay, perfect. So welcome back. We will now be solving for our direction on this angle. We need, as much as we need a magnitude, we also need a direction for any vector. So if I'm looking at this thing, I see that I solved for, from our reference angle, the adjacent and the opposite sides. So I know that that tangent of the angle represents that relationship. So I can say tangent of theta equals, and we know that's opposite. Okay, we'll just say opposite over adjacent, which equals, in this case, this is y, that is x. So we will say y over x. However, we're not solving for this relationship. We already know it. It's 5.16 over 6.34. I want theta. So I'm going to use inverse tangent. Inverse tangent of y over x equals, let's put in parentheses on that, equals theta. So here we go. Inverse tangent of y, 5.16. And I'm going to say this one more time. I get rid of the negative signs because I want a first quadrant angle. Because the way I'm going to describe this angle is based on the cardinal directions. I'm going to say this is south of east. So I don't care if this is negative or positive because I want something between 0 and 90 anyway. So 5.16 miles over 6.34 miles equals theta, and that equals, once again, time for a little calculator work here. We have inverse tangent of 5.16 divided by 6.34, opposite over adjacent, 39.1 degrees. 39.1 degrees. Okay, so now we have theta, our angle. So let's write out, I'm going to get rid of this guy right here, Pythagoras Theorem. So our overall total vector, all 5 of those vectors boiled into one. All 5 of those vectors added together, however you want to say it. Susan's total displacement is 8.17 miles, and then I always just say at 39.1 degrees. Check my little triangle real quick. This is south of east. S of E. There we have it. Problem solved. Okay, so that is how you can add a bunch of common vectors that you're going to see in any physics class. That is how you add them all together to get one resultant vector. Once again, my name is Clayton. I am a tutor in the Natural Sciences Tutoring Center at SCC. Stop by if you have any questions. Thank you very much for your time. Appreciate it.